What is the azimuth?
Used in navigation and in reporting the position of stars, planets, and other celestial bodies. The azimuth is the number of degrees between the direction of north, 0 degrees, and the direction in which the object is viewed from the perspective of the observer. In more mathematical terms, it is the angle between two vertical planes. One formed between the observer and the object observed, and the other formed by the observer and true north.
What is the jet stream?
The jet stream is a band of swiftly moving air located high in the atmosphere, and affects the movement of storms and air masses closer to the ground. The currents of air flow from west to east and are usually a few miles deep, up to 100 miles, 160 kilometers, wide, and well over 1,000 miles, 1,600 kilometers, in length. The speed at which the air travels in the jet stream is over 57.5 miles, 92 kilometers per hour, sometimes moving as fast as 230 miles, 386 kilometers per hour. There are two polar jet streams, one in each hemisphere. The jet streams meander across the troposphere and stratosphere. Up to 30 miles 48 kilometers high, and between 30 and 70 degrees latitude. There are also two subtropical jet streams, one in each hemisphere, that range between 20 and 50 degrees latitude. The subtropical streams flow between altitudes of 30,000 to 45,000 feet, 9,150 to 13,700 meters, and are even swifter than the polar streams, moving at speeds of over 345 miles, 550 kilometers, per hour.
How did Charles Fabry discover that the ozone absorbs ultraviolet light?
Fabry, 1867 to 1945, invented the interferometer, a device measuring how light waves interfere with each other. With fellow French physicist Albert Parrot, 1863 to 1925. He used this Fabry-Parrot interferometer to measure the Doppler effect on light in the laboratory. Then, in a 1913 experiment, he used it to learn that UV radiation is absorbed by the ozone layer.
What are the consequences when glaciers melt?
Glaciers that have melted in the Himalayas, home to the world's largest mountains, have filled up and burst the banks of nearby glacial lakes, filling rivers and causing widespread flooding and death to nearby populations downstream. Similar consequences will likely befall those now living near other glaciers around the world.
What is a gust NATO?
Seen near thunderstorm outflows, a gustnado is a weak vortex that does not touch the clouds. Gustnados usually do little more damage than breaking some tree branches and overturning lawn furniture.
Is static electricity similar to lightning?
Yes. When you generate a static charge by, for example, wearing wool socks and rubbing your feet on a shag carpet, and then touching a piece of furniture or a person, the spark that is released is just like a miniature bolt of lightning. Static electricity charges can generate 40,000 volts or more, which, as some people know, can be damaging to electronics, such as computers.
When do thunderstorms occur?
In the United States, thunderstorms usually occur in the summertime, especially from May through August. Thunderstorms tend to occur in late spring and summer, when large amounts of tropical maritime air move across the United States. Storms usually develop when the surface air is heated the most from the sun, 2 to 4 p.m. Thunderstorms are relatively rare only in far northern and coastal New England, as well as along the Pacific coast. Florida, the Gulf states, and the southeastern states tend to have the most storms, averaging 70 to 90 annually. The mountainous Southwest averages 50 to 70 storms annually. In the world, thunderstorms are most plentiful in the areas between latitude 35 degrees north and 35 degrees south. In these areas there can be as many as 3,200 storms within a 12-hour nighttime period. As many as 1,800 storms can occur at once throughout the world. Lightning performs a vital function. It returns to the Earth much of the negative charge the Earth loses by leakage into the atmosphere. The annual death toll in the United States from lightning is greater than the annual death toll from tornadoes or hurricanes. 150 Americans die annually from lightning and 250 are injured.
What is a heavy snow warning?
A heavy snow warning is issued when the National Weather Service expects an accumulation of 4 inches, 10 centimeters, or more within a 12-hour period. Heavy snow warnings differ from blizzard warnings in that they do not depend on strong winds for an advisory to be issued.
Could a sudden ice age like the one in the 2004 movie The Day After Tomorrow actually result from global warming?
No. That's Hollywood. In the movie, a scientist predicts, correctly for the plot of the film, which provides a lot of opportunities for special effects, that all the fresh water melting into the oceans will cause the Gulf Stream to dissipate. and that this will lead to the sudden onset of a new ice age. New York City freezes over in a day. And bizarre storm cells cause people to turn into popsicles in seconds. Ridiculous, say experts, though they admit that ice caps melting will indeed cause many adverse effects, such as rising oceans and changes in weather patterns. That said, it is interesting to note that ice ages can occur fairly quickly. Geologists and glaciologists estimate that some ice ages made significant advances through North America in spans ranging from a few decades to as little as 3 years. I heard that some glaciers in Alaska are growing, not shrinking. Is this true? It's true that many Alaskan glaciers, including, most notably, the Hubbard Glacier, have been advancing in recent years. The reasons for this are complex and may have nothing to do with whether or not climate change is occurring. To simplify what is the rather complicated science of glaciology, there are different types of glaciers. Some glaciers rest in valleys and tend to be more sensitive to changing temperatures. Others, including Hubbard, are known as calving glaciers. They terminate at an ocean and parts of them break away in a stunning spectacle known as calving. The 5 large glaciers in Alaska that are growing, including Hubbard, all have several commonalities. 1. They have previously experienced long periods of retreat only recently reversed, in the past century or so. 2. They all calve on shallow moraine shoals. 3. They all lay at the heads of long fjords. 4. They have positive mass balances that, by sheer force of weight, cause them to expand as gravity pushes down on them. And 5. They have small ablation areas, that is, small surface areas where melting and sublimation occur. Glaciologists note that glaciers with these qualities are not strongly influenced by even long-term temperature changes.
Who should be credited with inventing weather radar?
No one person decided to use radar for weather forecasts. With the technology already in place, it was simply adapted to this purpose when experiments in Britain and the United States showed that radio waves bounced off clouds. Radar was first used to specifically obtain weather data in 1949. But it was not until the mid-1950s that a weather station using radar technology was established in the United States. This happened after the eastern seaboard was hit by 2 vicious hurricanes in 1954 and 1955. The U.S. Weather Bureau was then authorized by Congress to create a national weather radar grid. And so the Weather Surveillance Radar, WSR-57, was founded in 1957. WSR systems used vacuum tubes and other technologies that were becoming outdated by the late 1970s. Despite the fact that vacuum tubes were in short supply, and other parts had to be hand-machined in order to keep the weather system running, Congress did not approve replacing the system until the 1990s.
What is the heat index?
The heat index is a measurement of what hot weather feels like to the average person for various temperatures and relative humidities. Heat exhaustion and sunstroke are inclined to happen when the heat index reaches 105 degrees Fahrenheit 40 degrees Celsius. The reason why it feels hotter to people when it is more humid is that the body cools itself by perspiring. Beads of perspiration help cool the skin as they evaporate. But when the air is too humid to allow for this evaporation, this natural cooling system no longer works well. The danger point for humans can occur when the heat index is between 90 degrees Fahrenheit 32 degrees Celsius and 104 degrees Fahrenheit 40 degrees Celsius. And when the heat index reaches above these temperatures, weather conditions become very dangerous indeed. At this extreme, heat exhaustion, heat stroke, or sunstroke may occur quickly. Especially during physical activity, and it is very important to stay in the shade and remain hydrated. The chart below provides the heat index for some temperatures and relative humidities.
Are stories about fish, frogs, and insects raining down from the skies real?
While the old saw about raining cats and dogs is just an expression, there have been reliable reports of very strange rains during which people are pummeled by frogs, grasshoppers, fish, and other bizarre creatures. For instance, in 1873 it was reported in a Scientific American article that frogs fell from the sky during a storm in Kansas City, Missouri. Both frogs and toads rained down on Minneapolis, Minnesota. During a 1901 storm, more recently, in 1995, a frog storm was reported in Sheffield, England. One possible explanation for amphibian rain is waterspouts carrying frogs and toads up into the air, where prevailing winds then dump them onto a distant location. The same sort of theory might apply to reports of raining fish. A couple living in Folsom, California, for instance, reported a fish rain in September 2006, and earlier that year a similar eyewitness account came from Manna, India. Scientists were not incredulous, explaining that waterspouts can kick up winds of 200 miles. 320 kilometers per hour that have been known to lift objects as big as sailboats. Other creatures, such as birds and flying insects, have been victims of weird weather, as well. It's not too much of a mental leap to conceive birds being caught in a strong storm that could injure or disorient them, causing them to fall out of the sky. Insects such as grasshoppers and crickets could just as easily be victims of such storms. In 1988, for example, meteorologists speculated that a swarm of red grasshoppers in Africa was caught up in strong winds and blown all the way to the Caribbean, where they landed in a massive insect rain shower.
Who contributed to early work in plate tectonics?
There were several key scientists who contributed to the study of plate tectonics as it became more favored in the late 1960s. One of the most popular scientists to discover evidence for plate tectonics was J. Tuzo Wilson. 1908 to 1993, by 1965, he described the origin of the San Andreas Fault, the large crack in the Earth's surface near San Francisco, California, as a transform fault, or strike slip, one of the major plate boundaries. In 1968, Xavier Lepichon, 1937, participated in the definition of the overall plate tectonics model and published the first model quantitatively describing the motion of 6 main plates at the Earth's surface. In 1973, he wrote the first textbook on the subject. Other geologists have made major contributions to the development of the plate tectonics theory. William Jason Morgan published a landmark paper in 1968 explaining the many tectonic plates and their movements. He also recognized the importance of mid-plate volcanic hotspots that create island chains such as the Hawaiian Islands. Walter Pittman III was instrumental in interpreting the pattern of marine magnetic anomalies detected around mid-ocean ridges, an indicator of active seafloor spreading and evidence of plate tectonics. And Lynn R. Sykes used seismology to refine plate tectonics. And he noted the connection between transform faults at the mid-ocean ridges and plate motion. He also co-authored Seismology and the New Global Tectonics in 1968, which relates how existing seismic data could be explained in terms of plate tectonics.
What is the Kyoto Protocol?
An international agreement initiated by the United Nations, the Kyoto Protocol is a document that aims to reduce global emissions worldwide in an effort to stem and eventually reverse global warming. Adopted on December 11, 1997, the agreement has been signed by representatives from 184 nations. A central aspect of the Kyoto Protocol is establishing scheduled reductions in emissions, reducing greenhouse gases relative to 1990 levels by 5% over the course of the years 2008 through 2012. Countries participating in the agreement can earn emissions-reducing credits by either reducing pollutants produced in their own countries or through a carbon market, which is a system of emissions trading. In other words, a country that wishes to allow more emissions within their borders can purchase emissions credits from countries with lower levels and still be in compliance with the treaty. Countries can also earn credits by sponsoring emissions-reducing programs in foreign nations or building clean factories and power plants in other countries.
What is the difference between climate and weather?
Climate is the long-term average weather for a particular place. The weather is the current condition of the atmosphere. So, the weather in Barrow, Alaska, might be a warm 70 degrees Fahrenheit. 21 degrees Celsius, but its tundra climate is generally polar-like and cold.
What are some of the erratic behaviors of tornadoes?
Tornadoes are famous for their ability to destroy one home or other building while leaving the structures next door completely intact. Such random acts of destruction occur either when there is one very slim tornado or there is a multiple vortex tornado or a tornado with several satellite tornadoes surrounding it. A rope tornado, for instance, can clear a path on the ground that is only a matter of several yards wide. On the other hand, the subvortices, or suction vortices, of a multiple vortex tornado can have widely varying speeds and widths. Sometimes, too, a tornado might not quite reach the ground, but it might be low enough to rip off the roofs of multi-story structures while leaving ranch homes and strip malls unharmed. Tornadoes can exhibit other erratic behaviors, too, weakening and strengthening as they travel, or circling back on themselves to hit the same location twice. The strength of the buildings, too, matters a great deal. As the developers of the enhanced Fujita scale recognized.
What U.S. city is particularly noted for its problems with smog?
Los Angeles has a rough time with smog. The brown haze that often lingers over the city is a result of several factors. Of course, the urban area is filled with cars and other sources of pollutants. But the natural environment conspires to make matters worse. First of all, very little rain falls in LA, which might attract tourists and new residents but does nothing to wash away pollutants, and secondly, the city is in a basin surrounded by mountains. Ocean breezes blowing in from the west keep air pollution from escaping in that direction. But then the smog finds another barrier in the mountains that lie east, north, and south of the city. Even before Spanish and other European settlers came to the area, the Native American Chumash tribe called what is now Los Angeles the Valley of Smoke. Because haze from brush fires and dust would be trapped there for long periods.
What is an indoor thunderstorm?
When the humidity is very low inside a building, static electricity can easily build up as people walk across carpeting, dragging their feet, and then touch a piece of furniture, a doorknob, or some other object. When this happens, a discharge of about 40,000 volts can occur in even a small spark jumping from your fingertips. Running a humidifier inside the home during winter can usually keep these indoor thunderstorms, a rather exaggerated term, at bay.
What is the connection between earthquakes and plate tectonics?
Only the lithosphere has the strength and brittle behavior to fracture in an earthquake. And as lithospheric plate boundaries push, pull apart, or grind against each other, earthquakes occur. In 1969, scientists published the locations of all earthquakes that occurred from 1961 to 1967. They discovered most earthquakes and volcanoes, too, they later learned, occurred in narrow belts around the world. Thus, it is now known that areas with frequent earthquakes and volcanoes help define the plate boundaries.
How fast does lightning travel?
The stroke channel of a lightning bolt is very narrow, perhaps as little as half an inch, 1.25 centimeters. It is surrounded by a corona envelope or a glowing discharge that can be as wide as 10 to 20 feet, 3 to 6 meters, in diameter.
What are near-Earth objects and are they dangerous?
There are hundreds, if not thousands, of NEOS near-Earth objects, which are asteroids with orbits that cross Earth's orbit. And NEO could indeed strike our planet, possibly unleashing cosmic destruction. As of early 2009, astronomers have tracked nearly 6,000 near-Earth objects. Of these, 765 have diameters of more than a mile across, and over 1,000 are considered potentially hazardous asteroids. FAS, meaning that their orbits take them uncomfortably close to Earth.
Is there weather outside the solar system?
In recent years there has been a flurry of activity among astronomers who are discovering more and more exoplanets. Over 200 have thus far been found, and most of these are gas giants. The reason for this is because gas giants, being very large, exert a greater gravitational pull. The most successful technique for finding exoplanets has been to observe how stars move. Observatories such as the Hubble telescope are sensitive enough to detect if a star has a slight wobble to it, which indicates the presence of planets and a solar system. Combining this method with infrared spectroscopy, it is possible to detect the molecular composition of distant planets. Carbon dioxide and monoxide, hydrogen, neon gas, water, and hydrocarbons have all been detected. Astronomers are quite confident that they are seeing planets outside our solar system that have atmospheres. And they speculate that some may have life-supporting liquids and gases.
How tall can thunderstorm clouds be?
Even a fairly average thunderstorm has a height of more than 20,000 feet, 6,000 meters. With the tallest storms being reported at over 70,000 feet, 21,000 meters.
What is a blizzard?
According to the U.S. National Weather Service, a winter storm is considered a blizzard when wind speeds reach 35 miles. 56 kilometers per hour and there is poor visibility of less than 1/4 of a mile, 400 meters. Snow does not need to be falling at the time. But blowing and drifting should occur with drifts exceeding 10 inches, 25 centimeters, deep.
How were kites once used in early meteorology?
Sites, when skillfully designed and flown, can reach extraordinary heights. The world record for a single kite being flown is 14,509 feet, 4,422 meters. The record was set in Kincardine, Ontario, Canada, on August 12, 2000, by Richard Synergy. Much greater heights may be achieved, however, when multiple kites are linked together. A chain of 10 kites set an American record in 1910, rising to 23,385 feet, 7,128 meters. And a collection of 8 kites reached 31,955 feet, 9,740 meters, in Lindenberg, Germany. In 1919. The earliest record of kites being used for meteorology comes from the University of Glasgow, where in 1749 two students, Alexander Wilson and Thomas Melville, wanted to measure conditions in the upper atmosphere. Since there were no airplanes or hot air balloons at the time, they used a kite.
How unhealthy is snow shoveling?
Heart attack rates increase sharply during the winter months in northern climates. Because people who are older or are not very healthy get too much exercise shoveling snow. Because more men than women tend to shovel snow. About 3/4 of winter fatalities after snowstorms are men. 50% of these men, too, are over 60 years of age.
What is a coronal mass ejection?
A coronal mass ejection is a huge blob of solar material, usually highly energetic plasma that is thrown outward into space in a huge solar surface explosion. Coronal mass ejections are associated with solar flares. But the two phenomena do not always occur together. When coronal mass ejections reach the space near Earth, artificial satellites can be damaged by the sudden electromagnetic surge caused by the flux of these charged particles.
What is a nor'easter?
A nor'easter is a storm along the eastern coast of North America that affects the region. With northeasterly winds with speeds up to 75 miles, 121 kilometers per hour or more. Such storms evolve when low-pressure systems accumulate humid air from the Atlantic Ocean or from the Gulf of Mexico, and combine it with cold dry air coming down from Canada in conjunction with a strong jet stream. The system rotates counterclockwise, bringing strong rainstorms in the south and, in winter, snow to the northeast. Nor'easters have wreaked havoc on the United States a number of times. For example, a February 1969 nor'easter dumped 70 inches, 178 centimeters of snow on Rumford, Maine, and 164 inches, 416.5 centimeters, on Pinkham Notch, New Hampshire. One of the worst nor'easters resulted in a superstorm in March 1993 that is still referred to as the storm of the century.
What are atmospheric teleconnections?
Atmospheric teleconnections refers to the way that conditions in the oceans, including such phenomena as El Niño, La Niña, and ocean currents, interact with and affect the weather.
What is climatology?
Climatology is the study of the world's climates and how they are changing over time.
What is long-range transport?
Long-range transport refers to the fact that winds, especially high-altitude winds, can carry pollutants over incredibly long distances. People once believed that pollutants from sources such as smokestacks might travel a few miles before settling onto the ground and water supplies. Now it is known that these particulates and toxic gases can make their way into the upper atmosphere. Scientists first started to become aware of this issue in the mid-20th century, when nuclear bomb tests resulted in radioactive clouds that would circumnavigate the planet. Acid rain causing chemicals can easily cross the entire United States. And, likewise, pesticides and herbicides travel long distances. Natural air pollutants, such as volcanic ash and organic material like fungi, spores, and pollen, can similarly range over long distances.
What is refraction?
Refraction refers to how light is bent as it passes from one transparent medium to another. For example, from air to water. This happens because light travels at different speeds, depending on the medium. Refraction is the reason why we see rainbows.
Is Yellowstone actually a supervolcano?
Yellowstone National Park is renowned for its scenic geysers and hot springs covering some 2,300 square miles, 3,800 square kilometers. The energy for all this hot water actually comes from volcanic energy below a plateau that is actually a giant caldera. Geologists estimate that this massive volcano last erupted about 640,000 years ago with an energy equal to 8,000 Mount St. Helens eruptions. One can only imagine the destruction such an explosion would have wreaked. A nuclear winter would have ensued, acid rain would have fallen from the sky. And some scientists believe that the human race was driven almost to extinction at the time. Since the volcano is still active, it could happen again at almost any time. Some parts of Yellowstone have risen about 29 inches, 74 centimeters. Since measurements were first taken in 1923, which indicates a buildup of magma beneath the crust. It is only a matter of time before this energy is released. And Yellowstone is not the only such supervolcano. The last such eruption came from Toba, Sumatra. About 70,000 to 75,000 years ago, and other, as yet undiscovered supervolcanoes might exist.
Occurring during the summer, how warm can it get in Antarctica?
Antarctica is not always an icebox perpetually below freezing. During the summer months, it can often get into the 40s and 50s Fahrenheit, 4 to 14 degrees Celsius. The warmest temperature on record thus far on the continent is 59 degrees Fahrenheit. 15 degrees Celsius, at Vanda Station on January 5, 1974.
What is a thermoscope and who invented it?
The history of the thermometer goes back to the ancient Greeks. It is not known exactly who invented a working thermometer, but the earliest record has Philo of Byzantium creating what was called a thermoscope back in the 2nd century BCE. Similarly, crude devices using the expansion of water due to temperature were used throughout the centuries. The prolific Renaissance inventor and artist Galileo Galilei, 1564 to 1642, improved the air thermoscope in 1593. The thermoscope he created uses a different approach to measuring temperatures than the thermometer. Instead of containing a fluid, such as mercury, that is sensitive to changes in heat and cold, the thermoscope suspends several objects within a transparent tube.
What are dust devils?
These columns of brown, dust-filled air, which can rise dozens of feet, are not as evil as the name suggests. They are caused by warm air rising on dry, clear days. Winds associated with dust devils can reach up to 60 miles. 96.5 kilometers per hour and cause some damage. There have been reports of dust devils as tall as 5,000 feet, 1,500 meters. They are generally not as destructive as tornadoes and usually die out pretty quickly. Though some have been known to displace as much as 50 tons, 4,500 kilograms, of dust and light debris. One of the biggest dust devils ever recorded was seen in Bonneville Salt Flats in Utah. It was hundreds of feet tall, and it continued on its way for about 40 miles, 65 kilometers.
What is the Saffir-Simpson hurricane scale?
The Saffir-Simpson Hurricane Damage Potential Scale, which is the full name, is a 5-point scale invented in 1971 by engineer Herbert Saffir, 1917 to 2007, and Robert Simpson, 1912, a hurricane expert. Rating hurricanes on a scale of 1 to 5, with 1 being the weakest and 5 the strongest. The scale ranks these storms according to peak wind speeds and the amount of damage they cause.
Do all scientists agree that global warming is caused by human beings?
In short, no, not every scientist believes people create global warming. Although more and more scientists are becoming convinced that we are seeing a significant change in our climate. There are those who argue that it has more to do with solar cycles. Some meteorologists have also noted that, historically, climate warming has preceded increases in carbon dioxide levels, not the other way around. This is because when the Earth warms up, it also warms the oceans, which hold much of the world's carbon dioxide in the form of carbonic acid. When the oceans get warm enough, the carbon dioxide is then released into the atmosphere.
What is one strange warning sign that lightning may be about to strike?
As the static charge begins to build as a precursor to a lightning stroke, people's hair may stand on end and you can feel the static charge in the air. It has also been known to happen that a plastic raincoat will begin to rise into the air, or that a cast fishing line will bizarrely remain suspended in air. Any of these signs are a warning to seek immediate shelter.
What is eutrophication?
Eutrophication is the excessive buildup of nutrients in lakes, ponds, and other water bodies as a result of river and stream runoff containing pollution from fertilizer, sewage, and other waste products. While more nutrients in the water might at first sound like a good thing, it actually has harmful side effects, such as algae blooms that deplete water of oxygen and kill off aquatic species and other wildlife. Factory farms and private residents who fertilize their lawns are major culprits of this type of pollution. If you live by a fresh water source, such as a pond or stream, you can lessen the negative effects of runoff by creating a natural plant barrier between your lawn and the water. Among the plants that make ideal buffers are willow trees, birch, green ash, red maples, buttonbush, spice bush, some dogwood species, water oak and pin, sycamore, and smooth alder. These and other plants absorb the excess nutrients while also preventing erosion.
How high would the oceans rise if all the ice sheets melted?
It is estimated that if all the ice sheets melted, including the polar ice caps, ice on Greenland and Iceland, and all the glaciers on the planet, the average worldwide sea level would rise by about 250 feet, 76 meters. Such a rise would decimate almost all coastal cities, shrink the living space on all the continents, cause massive climate fluctuations, and change our lives forever.
How does the motion of Earth around the Sun cause the seasons to occur?
Some people mistakenly think that the seasons are caused by Earth being farther from the Sun in winter and closer to the Sun in summer. This is incorrect. Earth's elliptical orbit is close enough to a perfect circle that distance is not the reason. In fact, Earth is closest to the Sun in early January and farthest in early July, which is exactly the opposite of our summer and winter seasons. The reason for the seasons has to do with the angle at which sunlight strikes any particular place on Earth at any given time of year. The angle changes throughout the year because the tilt of Earth's axis differs from the ecliptic. Since the Earth is tilted 23.5 degrees, the Sun's rays hit the northern and southern hemispheres unequally. When the Sun's rays hit one hemisphere directly, the other hemisphere receives diffused rays. The hemisphere that receives the direct rays of the Sun experiences summer. The hemisphere that receives the diffused rays experiences winter. Thus, when it is summer in North America, it is winter in most of South America, and vice versa.
What are the hazards of dust storms?
Dust storms regularly occur in such places as the Sahara and Gobi deserts. Not only do dust storms destroy farms, they also invade homes and other buildings and can cause health problems ranging from stinging eyes to lung and other respiratory problems. Lowering visibility. Dust storms have been known, too, to cause traffic accidents just as well as a snowstorm can. In 1995, for example, 8 people were killed on the New Mexico-Arizona border when a dust storm blew across a highway.
What is a brown cloud?
The brown haze suspended over cities such as Los Angeles, Mexico City, and Cairo, Egypt, is sometimes referred to as a brown cloud.
Have hailstones ever proven to be deadly?
Strong hails can be heavy and plummet at speeds that have been known to break windows, dent cars, damage roofs, destroy crops, to the tune of about $1 billion annually in the United States alone, and, yes, even kill. In July 1953, for instance, 30,000 ducks were found dead after a hailstorm in Alberta, Canada. In Montana, a July 1978 hailstorm killed about 200 sheep. In the United States, not many people have been killed as a result of hail. The last reported death was on July 30, 1979. A hailstorm in Fort Collins, Colorado, killed an infant and injured about 70 other people. Storms in other, poorer regions of the world are more common. However, because poorly built shelters collapse, killing those inside. For example, in Sichuan province, China, a fierce hailstorm injured 9,000 people and killed 100 on March 22, 1986. A month later, that same year, 92 people died in Gopalganj, Bangladesh, with some hailstones reported to weigh over 2 pounds, 3 kilograms.
What happened when Mt. St. Helens erupted?
On the morning of May 18, 1980, a magnitude 5.1 earthquake struck beneath the Mt. St. Helens volcano in Washington state. Later that day, the volcano exploded, initiating a massive avalanche that tore away the northern slope of the mountain and created the largest landslide in recorded history. The conical volcano went from about 9,678 feet, 2,950 meters, to 8,366 feet, 2,550 meters, in height, releasing a giant plume of ash and gas high into the atmosphere. A lethal pyroclastic flow of hot steam, gas, and rock debris raced down the slope of the mountain, traveling as fast as 684 miles, 1,100 kilometers, per hour. A fine ash dust was propelled into the upper atmosphere, stratosphere. At heights reaching up to 15 miles, 22 kilometers. Spreading to the east by the prevailing westerly winds and eventually reaching all over the world. In a short time, The ash blanketed central Washington, the prevailing winds carrying an estimated 540 million tons of ash across 22,007 square miles, 57,000 square kilometers, of the western United States. People in towns nearby, and some as far away as western Montana, were affected by the rain of ash. Car radiators were clogged, upper respiratory problems worsened. Air and ground travel were disrupted, and a thick coating of ash particles covered everything outside. Despite such impressive statistics, the Mt. St. Helens eruption did not disrupt climate on a worldwide scale. There are two reasons for this. 1. The volcano did not release that much sulfur dioxide compared to some other major eruptions. And 2. The eruption blew out the side of the mountain, thus shooting debris at an angle and not as high into the atmosphere as might have otherwise happened.
What is the shape of a raindrop?
Although a raindrop has been illustrated as being pear-shaped or tear-shaped, high-speed photographs reveal that a large raindrop has a spherical shape with a hole not quite through it, giving it a donut-like appearance. Water surface tension pulls the drop into this shape. As a drop larger than 0.08 inch, 2 millimeters, in diameter falls, it will become distorted. Air pressure flattens its bottom and its sides bulge. If it becomes larger than 1/4 inch, 6.4 millimeters, across, it will keep spreading crosswise as it falls and will bulge more at its sides, while at the same time, its middle will thin into a bow tie shape. Eventually, in its path downward, it will divide into two smaller spherical drops.
Are there other types of tornado like whirlwinds?
Certainly. Smoke from forest fires and ash and steam from volcanoes can often stir about in vortices that look like weak tornadoes.
Can weather cause bales of hay to catch fire?
Dry bales of hay are perfect tinder to start a fire. The most likely scenario for a hay bale to catch fire is when it is struck by lightning during a thunderstorm. But green, freshly harvested hay can be incendiary, too. Methane gas can build up within the piles of hay as the foliage decomposes. And when the temperatures are hot enough, the methane can combust. This happened, notably, in the summer of 1995, when hay bales ignited in several U.S. states, especially in Missouri.
What is a blue sun?
An even rarer event than a blue moon is a blue sun. As with a real blue moon, the sun can appear bluish as a result of fires. Volcanic eruptions, or sandstorms coating the air in dust, ash, or sand.
How much rain does it take to make a flood?
The amount varies widely for different areas. In some U.S. western deserts, or in some large urban areas, just a few minutes of strong rain will cause a flash flood in canyons and low-lying areas. In areas prone to greater rainfall amounts, it often takes quite a bit more rain. Sometimes a few days or weeks' worth, to cause rivers to overflow and dams to fill up, raising concerns of those who live downstream. Areas that normally receive more rainfall have better natural drainage systems and are usually home to plants that readily absorb the extra water.
Are there other terms for describing clouds?
Yes, in addition to the major naming conventions for clouds based on altitude and characteristics, there are also a variety of other Latin terms used to describe clouds. These names can be appended to the main names of clouds. For example, a cumulus castellanus is a cumulus cloud, with formations on the top that look like castle towers. Below is a full list of other descriptors for clouds.
What was the Great Flood of 1993?
Heavy rainfall caused river flooding in 1993 that was so severe in Iowa that, when observed by NOAA sensors, the state looked like a sixth Great Lake. The Mississippi River was 7 miles wide at some points, and the Missouri River also spilled over its banks, causing nearly $20 billion in property losses, 48 deaths, and the evacuation of 85,000 people.
How many layers does the Earth's atmosphere contain?
The atmosphere, or skin of gas that surrounds the Earth, consists of 6 layers that are differentiated by temperature. 1. The troposphere is the lowest level. It averages about 7 miles, 11 kilometers, in thickness, varying from 5 miles, 8 kilometers, at the poles to 10 miles, 16 kilometers, at the equator. Most clouds and weather form in this layer. Temperature decreases with altitude in the troposphere. 2. The stratosphere ranges between 7 and 30 miles, 11 and 48 kilometers, above Earth's surface. The ozone layer, which is important because it absorbs most of the sun's harmful ultraviolet radiation, is located in this band. Temperatures rise slightly with altitude to a maximum of about 32 degrees Fahrenheit 0 degrees Celsius. 3. The mesosphere, above the stratosphere. extends from 30 to 55 miles, 48 to 85 kilometers, above the Earth. Temperatures here decrease with altitude to -130 degrees Fahrenheit, -90 degrees Celsius. For the thermosphere, also known as the heterosphere, is between 55 to 435 miles, 85 to 700 kilometers, above Earth's surface. Temperatures in this layer range to 2696 degrees Fahrenheit, 1475 degrees Celsius. 5. The ionosphere is a region of the atmosphere that overlaps the others, reaching from 40 to 250 miles, 65 to 400 kilometers. In this region, the air becomes ionized, electrified, from the sun's ultraviolet rays. It is divided into 3 subregions. 1. The D region, 40 to 55 miles, 65 to 90 kilometers. 2. The E region, also called the Kennelly-Heaviside layer, at 56 to 93 miles. 90 to 150 kilometers, and 3, the F region, 93 to 248 miles, 150 to 400 kilometers, which is further separated into the F1 layer and the F2 layer, also called the Appleton layer, with the dividing line being at about 150 miles, 240 kilometers, above sea level. 6. The exosphere lies above the thermosphere and includes everything above 435 miles, 700 kilometers, high. In this layer, temperature no longer has any meaning.
What does it mean when we say something is on the lee side of the wind?
If a person is standing on the lee side of something, say, a building or rocky prominence, then he or she is protected from the wind because that obstacle is between him or her and the oncoming wind.
Was the 2005 New Orleans disaster caused by a flood or a hurricane?
The initial cause of the disaster was Hurricane Katrina, which whipped up tides and sea water against a very fragile levee system that protected New Orleans. The city is 49% below sea level, and so when the man-made levees broke, flood waters moved in and inundated much of the city.
What physical evidence shows that the continents move?
Scientists have gathered plenty of evidence that shows the continents move over time. For example, the shape of the continents and their fit was determined by Sir Edward Bullard in 1965. He did not cite the usual continental shapes we see, but he measured the real edge of the continents, the continental slope, an area that shows a much better fit at the 6,560 foot, 2,000 meter, depth contour than at the shorelines of continents. Other scientists matched the continental geology on either side of an ocean. For example, the mountain belts of the Appalachians and the Caledonides are relatively similar geologically, as are the sedimentary basins of South Africa and Argentina. Another way to prove that continents move over time includes paleontology, in which similarities or differences of fossils on certain continents indicate a match. For example, there are similar Mesozoic-era reptiles in North America and Europe, a time when scientists believe those two continents were joined together. Similar Carboniferous and Permian flora and fauna are found in South America, Africa, Antarctica, Australia, and India. In contrast, no doubt after the continents were well separated, there is a wide diversity of organisms in the Cenozoic era.
What is a mackerel sky?
Mackerel skies are the result of altocumulus or cirrocumulus clouds forming a distinctive pattern that looks like the scales on a mackerel fish's back.
How are different types of climates classified?
The German-born, Russian climatologist Vladimir Koppen, 1846 to 1940, developed a climate classification system that is still used today, albeit with some modifications. He classified climates into 6 categories: tropical humid, dry, mid-latitude, severe mid-latitude, polar, and highland. He also created subcategories for 5 of these classifications. His climate map is often found in geography texts and atlases. In 1931, American geographer and climatologist Charles Warren Thornthwaite, 1899 to 1963, published The Climates of North America, according to a new classification, which takes into more thorough consideration how differences in geography affect local climates.
What is the Space Weather Prediction Center, SWPC?
Part of the National Weather Service, the SWPC monitors solar and geophysical events that can affect communications, power grids, artificial satellites, and navigational systems.
What caused a temporary but dramatic change in climate in 1816 called the year without a summer?
On April 10, 1815, Mount Tambora erupted on the Indonesian island of Sumbawa. After what some scientists believe was a period of inactivity of about 5,000 years. The massive blast shot an estimated 24 cubic miles, 100 cubic kilometers, of rock and 220 million tons, 199.54 billion kilograms, of sulfur dioxide, almost 29 miles, 40 kilometers, into the atmosphere. Everything within 400 miles, 645 kilometers, of the blast was plunged into near total darkness. Tsunamis reaching 16 feet, 5 meters, in height crashed onto surrounding shorelines. After the initial eruption, the volcano continued to erupt through mid-July. To make matters worse, 2 previous volcanic eruptions also contributed to dust and debris being thrown into the Earth's atmosphere. The volcano Soufriere Saint Vincent erupted in the Caribbean in 1812. And 2 years later Mayon volcano exploded in the Philippines. In addition to all this volcanic activity, there was an increase in sunspot activity, including one particularly large sunspot that was so big it could be seen with the naked eye. All of these events conspired to lower temperatures dramatically all over the planet. Canada, Europe, and the United States were all very hard hit, particularly in the East and Midwest, where crop failures were extensive in 1816. During that summer, snow fell a few times in New England in June. Vermont saw ice on its lakes in June thick enough to skate on, while snow was as deep as 18 to 20 inches, 45 to 50 centimeters, deep. After this bizarrely cold summer, the winter of 1816 to 1817 was rather mild. But that did not matter since the crops were all ruined.
How was the jet stream discovered?
With the advent of airplanes that could cruise at elevations of over 30,000 feet, over 9,000 meters, high, pilots such as World War II bomber pilots flying over Japan and the Mediterranean Sea discovered the effects of the jet stream on their aircraft.
Is it possible to fry an egg on the sidewalk?
Well, not really. Concrete sidewalks are not actually the best place to cook an egg. Not to mention they aren't very sanitary. On very hot days, the sidewalk temperature can get to about 145 degrees Fahrenheit. 62.8 degrees Celsius, but an egg requires about 158 degrees Fahrenheit 70 degrees Celsius to cook thoroughly. On the other hand, if you put an egg on blacktop, you are more likely to be successful because the black surface will absorb more heat. Even better is using a metal surface. And people have been known to cook an egg on the hood of a car on a summer's day.